Transmission bands are a holding element only. So while clutches could be holding or driving, a band can only be a holding element. And the reason is because the one end of the band has to be anchored into the case somewhere or somehow, because the other end is what's going to be articulated by a servo or a lever being actuated by a servo, that it has to have something to run tension against. So one end of the band is anchored in the transmission case and the other end is operated by a hydraulic servo. And they usually will wrap around a drum. Now that drum might also be a clutch drum. So whatever planetary component that clutch drum drives when it's applied, because it's rotating, well, when that clutch turns off, that band could come on and then it could also hold that planetary component. So in this case here, what we have is a clutch drum here, which could drive an input shell, which would then drive the rear or reverse sun gear. Or if that reverse clutch turns off, then we can actually have the drum be held by the band, because it's going to wrap around it, which is going to hold the shell, which is then going to hold the rear reverse sun gear. So that sun gear could be held or it could be driven. Now it won't be done, they won't do both at the same time, but that's what's going to happen. Now the different types of transmission bands, really there's just two groups. There's a single wrap band and then there's a double wrap band. So the single wrap band is this guy over here. There's our S for single. And then our double wrap band is this one on this side. So it's pretty simple. This one has a single layer of a sheet metal band that goes around a drum. Okay, so it's single. And then this one here is oftentimes going to be cast iron. It's just cheaper to make it that way, and it ends up being a pretty strong band. However, it is a slow applying band. And what this one has is, if you look at it, we've got a layer here, and a layer there, and a layer here, so they call this the double wrap band. Now the reason it's double is because this band section here is going to be going in this direction for application, and then this band section is going to be going this direction, and this one is going to be also going in that direction. So we have two one way and then one the other, two directions, double wrap band. And in a lot of cases, the double wrap band inside the transmission is usually going to be used for manual low or reverse. And most of the time, that band is actually going to be perfectly fine unless the customer manually shifts it while they're racing it or driving it really hard. The single wrap band, it is not as strong as a double wrap band, but a single wrap band will apply much more quickly because there's less force holding it off of the drum, because it's just a thin piece of sheet metal, whereas this one over here is a piece of cast iron, and they just tend to be much more slowly acting on the double wrap bands. So how they apply is by the use of the servo. And if we look at this illustration, we have, let's start over here on the left, this green thing right here is our servo. Okay, so we draw that out here and we'll draw right in the servo. Okay, and the servo is a hydraulic piston that whenever this cavity behind it gets filled with automatic transmission fluid at pressure, it's going to cause that servo to go, in this picture, go off over to the left. Now right here, almost circled it, and then right here, now this is a round component, so this is a round piece. Those are the servo seals or servo piston seals. They're rubber seals. They're going to keep that fluid from leaking from one side to the other. Now, if we come over here to the, well, let's first talk about this, but we see that this piston rod right here is pushed against, and it's just sitting there and waiting, but they have illustrated an air gap in between the band and the drum, okay? Now over here on the applied side, we have this transmission fluid that comes in here. It builds up pressure and it causes that piston to move off to the left. And when it does that, the band is actually being pulled down in this direction because it's anchored here in the case. It then tightens up around that drum and that drum stops rotating. Other things about this system, the servos, they need a way to return, and especially on single wrap bands, because there's not a lot of spring pressure in a single wrap band. So that band isn't going to push the piston back. So they a lot of times they're going to use a spring, and that's what they're showing in here. This is actually a coil spring. Another method that they will return it is if they'll actually use hydraulic pressure on the front side of the piston. So the back side gets apply pressure, the front side can get disengagement or return pressure for the piston, the servo. Okay. Now on the table I have the example of the band out of this transmission that we're working on. Now this is the new one. Because I can't, no, there's the old one. Let me go grab it. There we go. So on the table, I have the example of the band out of our transmission. This is the 2/4 band, and we see that it's in this shape here like this. Now this band has an anchor point on one side. This little hole right here, there's a pin that slides through the case and engages that point. And then this side over here is where the servo for the 2/4 band actually applies and causes this band to contract. Now what does it wrap around? Well, it's going to wrap around our high reverse drum right here, the clutch drum. So we can see that if I were to squeeze this, you know, I wouldn't be able to turn it separately. I can let it go, and now I can rotate it. Okay, so I can rotate it easily, but then I squeeze it. Oh, now I can't anymore because that band is applied. Now what's applying it is the actual servo, which we took out of the transmission. Move the band out of the way. Oop. So here's our servo, and this servo is what presses against the pin, or sorry, the pin is what presses against the band to contract it around the drum. Now things to look at, during disassembly I had mentioned, if you're going to reuse a band, you don't want it to spring all the way, you don't want it to spring all the way open. You want to hold it shut because the friction material on the inside, this paper material right here, it's been formed to this diameter for its whole life. And whether that's 5,000 miles, 10,000 miles, 100,000 miles, this paper material is formed. So if you were to let it open up, you could actually open the cracks or create cracks in the material and requiring a replacement. Now these bands in this particular transmission are exceptionally cheap. I think a relined band, which is what I bought, is on the order of about $12. I know they used to be about $5 or $6, probably, I don't know, 10 years ago. But what they do is they actually remove the old material and then they glue on a new material, and that's what's considered a relined band, kind of like retreaded tires. They're good bands because they're using original steel with a new material on the inside. Of course, a new band, you know, is going to be like $18 or $19 compared to $12. So, you know, you can go one way or the other. Now, the drum that has the band wrapping around it, you do have to inspect it whenever you disassemble it, because if we look at this one, we can see it has some discoloration. And not that this was slipping inside the band, but during application, or possibly it could be due to the check ball that was stuck in the separator plate, maybe this band was partially applying when it wasn't supposed to, or maybe this band that was wrapping around this guy was not clamping as tightly as it should have, and we actually have some burnishing on the outside of this. Now this isn't bad. If you run your finger across it, I can barely feel any deviations in the surface. And I can tell that, you know, while it got hot, it didn't get exceptionally hot, because there'll be times where these things will be blue. You'll actually have grooves cut through them because of the friction material is embedded with harder metals, and it just wears away the drum. And that necessitates a new drum. So there we go. We got our drum, and then we have the band that wraps around it. Okay. And that's bands. I don't have an example of a double wrap band here right now, but I do have them in school, and you'll get to see that. All right, on to the next thing. So one-way clutches. One-way clutches can be a driving or they can be a holding element, meaning they could be applied with torque and counter rotation to drive a component, or they can be applied with counter rotation to hold a planetary component. And they're not activated by any hydraulics. They're actually activated by that counter rotation and torque. It causes them to lock up. Now there's three main types of one-ways. There's the rollers type, the sprag, and then the mechanical diode. I have examples of the roller and sprag here. Mechanical diode, it's a pretty simple mechanism because we've probably all ridden a bike with it, or we surely use it every day when we're working on our cars or trucks or whatever. So the roller clutch here, it has our three components. We have an outer race, okay, so this outer race is this light blue section here. We have our inner race, which is this dark or light green, and then we have our rollers. Now there's another piece in there that's not illustrated, and that piece is the springs. So these springs are right here on this one, I believe, and those springs are pushing. Actually, no, I think I did that wrong. So the springs are actually pushing the rollers this way here. So the springs are pushing the rollers in this picture, which isn't a great picture, in the counterclockwise direction. Now I do have an example of this right here on the table, and we'll look at that in a second. So the way this one works is there's ramps built into this outer race. So if we could illustrate this a little bit better, there's a ramp like this, and then a ramp like that, and then a ramp like that. And the roller is allowed to roll if that roller's up in this ramp section where there's a lot of space in between the inner race and the outer race's ramp. But what happens is if we take this inner race and we rotate it clockwise, this roller is going to go down into this narrow section, eventually getting into a section where it's too small to fit, and in unison, all of these rollers will stop and lock up. And that means that the outer race will not be able to rotate at any speed different than the inner race, but only if the inner race is going clockwise. All right, so that's the roller one way. The sprag style, this one here, they're shaped with a one short and a one long dimension. So these are the sprags. And what they have here is illustrated, the actual sprags, the purple things. And then we have two races. Now in the one-way roller clutch, the inner race and the outer race they weren't shaped the same. They didn't have the same features. The inner race looked like a bearing race. The outer race on the roller clutch had the ramps cut into it. Now with a sprag clutch, the inner race and outer race are both bearing races, meaning they're very smooth machined surfaces that accommodate a bearing. And the way this one works is if you look at this guy from this to this point, that sprag is a specific distance. But if we were to look at it in the other direction, from here to here, this sprag is actually shorter. So in this case right here, if the inner race were allowed to rotate clockwise, if the inner race is if you're trying to rotate the inner race clockwise, those sprags would actually tip over, exposing their short dimension. And if you were to try to counter-rotate it counterclockwise, then those sprags would catch traction and they'd all try to stand up and engage in their long dimension, and they'd all lock up in unison. And that's the big thing about one-ways, is that all of them have to work for this one-way mechanism to work perfectly. The roller one-way and the sprag one-way. If we start to have a couple of these break down, or maybe they get stuck or become lodged in there somewhere where they're not allowed to pivot or roll in the roller, then that whole one-way clutch will start to fail. These require that all of them work in unison. So that's that one. Then we come to the last one, which is a mechanical diode. Now this one here is a section view of it, and we see an upper and lower race. And they're going to be called upper and lower because that's how you put it on the table to analyze it. But in the vehicle, this upper race right here, which is this section here, that would be called the inner in our case. So that's inner. There we go. There's the inner race. And then this lower section, which is the largest portion of it, is called the outer race because it is exposed to the outside of the whole assembly. So that's the outer. And I'm just saying this because that's just how they do it. A-O-U-T-E-R. I think I got that right. There we go. Close off that O. So there's our outer race. And the way that this one works, or the components within it, we have our upper race, our lower race, and then we also have these struts, which is basically a little piece of metal, and it's going to have a shape to it. It will be, I don't know how you call it, but it's going to have, it's basically a flat plate. And on one side it has a wide ear and the other side it has a narrow ear, and that's for assembly. And then beneath that piece, which is not shown in this because it might actually be here, but there is a spring. Okay. Now something to notice is that there is a ramp inside or built into the upper race. There we go. And the upper race, it can rotate separately of the inner race. But if I were to take this upper race and push it in this direction or rotate it in that direction, this ramp would slide across, and then the strut would slowly get depressed down to where it's below the surface, compressing the spring, and you'd hear the clicking sound as it rotated around. However, if we reversed our direction and we went the opposite direction, you can see what's happening is that if that upper race then goes off to the left, the strut assembly slides up the ramp this way and it hits this section here called the crotch of it, and it actually locks it from here to here. And because they're all solid pieces, they all lock in unison. And mechanical diodes or ratcheting one-ways, they'll sometimes have 4, or they could have 8 or 10 ratchets or struts built into them, and that's just the mechanism that they decide to use. Now, roller one-way, sprag one-way, they're kind of falling out of favor because they are relatively expensive to manufacture. But when it comes to mechanical diodes, there is very little, very precise machining that has to happen. They're actually mostly assembled or mostly manufactured using a sintered metal. So they actually kind of like powdered metal assembly. They press it into shape, so it's kind of like a sand mixture. They press it into shape, then they send that piece of metal through an oven, and it sinters it, or it causes everything to adhere based on the alloys that are in it. And once they have the lower race, the inner race, those things are all powdered metal, and they pretty much come out to size from the oven, from the sintering oven. And then they'll have a thrust plate that presses in the top, and then the struts and springs. They're super cheap. There's no precision grinding required, where you have with rollers and sprags, you have precision grinding required on the various surfaces inside them. So mechanical diodes are starting to I wouldn't say they're starting to. They are very popular because of cost. The other thing about them is that they are very compact. A lot of clutches will actually, the mechanical diode will replace a pressure plate inside a clutch drum. So you have a clutch that can drive in one direction, coast in the other, and in the case of, let's say, they need engine braking, they can apply the clutch, and it's going to do exactly the same thing, but in both directions. But because that pressure plate is a one-way, they don't have to accommodate it anywhere else in the system, so they take the length of those two components and they compress it just into the drum. So they're very space-saving. Here we are at the table. We've got our one-way. This is the sprag style out of our transmission. And what I'm going to do is remove the snap ring from the inside. If I can get that out of there. There we go. So I'm just going to remove this snap ring, and I'm going to expose the mechanism on the sprag assembly. Now, one thing that you'll see is that rollers were oftentimes just called sprags all the time. It didn't matter, if it was a roller, a mechanical diode, or a sprag, they're just all called that. So inside this one, you can see that we have these sprags. Let's see if I can get that to focus better. There we go. We actually have our sprag assembly inside this. You can see we've got a series of sprags that go all the way around this race. We have our outer race, and then we have our inner race. if I try to rotate it let's call it, what's that, in the clockwise direction here, it's going to be allowed to rotate. But if I then try to rotate backwards, I can't rotate it any at all in the reverse direction, because those sprags are all trying to stand up to their taller dimension, causing it to lock up. So that's our sprag assembly. You can assemble this one backwards, and that's not a good thing, because if you were to put this inside the transmission with this guy flipped upside down, then this sprag would not work. And let's say it's just for first gear. Whenever you tried to take off, instead of the sprag holding and driving, I wouldn't say holding, but instead of it driving a planetary component, it's going to freewheel, and your power is not going to be transmitted through. So you need to make sure that you do note the direction of the rotation and the direction of the lock whenever you're disassembling it. Or you look in the workshop manual to make sure that you do it correctly. So you need to make sure that you do assemble it in the proper direction. So the other style that we have is the roller style. And in this one, what I'm going to do is I'm going to pop out this inner race, and you're going to actually see the rollers down on the inside of this component. There we go. So we have our rollers down on the inside of this race. Now, these normally can't be installed backwards, but you know, I thought a lot of things couldn't happen until I taught. So let me see if I can pop one of those rollers out. And all this is just a roller bearing. That's all it is right there. Let me get that in focus. Let me try and, there we go. So it's just a roller bearing that's located inside the assembly here, and our outer race is this component here, and the outer race of this is where the ramps are. Now I'm going to be replacing this one in this assembly because the rollers in this assembly they're blue. For some reason they've gotten hot. I'm going to pop out that unit, and we can actually see down inside there, we see the actual ramps right here, and the rollers are going to roll down inside there against the ramp. So in the freewheeling direction, in this case, the inner race is going to be going in this direction. The roller is going to be in a large part of the race, and if you were to rotate the inner race in a clockwise direction, all the rollers together would catch traction and start to push up in the shallow part of the ramp, and that would then cause it all to lock up. But again, they need to work in unison, because if you look at all the ramps around this thing, if one of them fails, that means that race could shift over to that side and loosen all of them up, and you could have a one-way clutch that locks up intermittently or doesn't lock up at all. And then in the worst case, you could probably have one that locks up all the time. So that's one way. Just remember, sprags, rollers, mechanical diodes, you know, they all work in. They have the same function, but they work with different methods. And in this case here, I actually have our new assembly right here, and they're very difficult to install upside down. So yeah, you know, I'd say in this case, if you installed it upside down, you did something really special. On the sprag assemblies like this, you put that one upside down, I could expect that to happen. That could be considered normal. All right, so the video after this, because we've gone through the clutches, we've gone through the bands, the different types of seals, is that we're actually going to be servicing the individual clutches on this transmission. And then we're going to, now we've already disassembled our reverse input, so I'm going to have to put that back together so we can go through the whole procedure for disassembly, cleaning, inspection, reassembly, and any final measurements. And then we have our input drum with the various clutches inside it. So, I guess that's everything for this video here, so we'll see you next time.